In this video, I will be going over transformations of graphs. So we will be talking about what makes a graph go up or down or left or right, or what causes a vertical stretch or a vertical shrink, what will reflect the graph over the x-axis, and I'll teach you some tips and tricks on how to make graphing easier when you are given an equation. Let's get into it. The first thing to think about when you are graphing an equation is the parent function. So here I have some examples of parent functions. What the parent function is it's the most basic form of that function. So for the linear one, I have f of x equals x. So it's just an x. There's no other numbers or anything added to it. Again, this is just the most basic form of that equation. So we have f of x equals x for the linear example. And then absolute value, f of x equals the absolute value of x. And quadratic, f of x equals x squared. So these are the graphs of the parent functions. So when you are graphing these, think about these parent functions as your starting place. So this is what you start with, and then from there, we add all of the transformations. Here is an example of a translation on a linear function. So we have the parent function, f of x equals x, or you could think of it as y equals x. Either way, just the f of x is function notation. So that would be the red line here. So you can see it goes through the origin at 0, 0, and the slope is just 1. It goes up 1 over 1, up 1 over 1, up 1 over 1. So that is your parent function for a line. And then if we take the equation f of x equals x plus 3, then you can see, that's the blue line, you can see that we moved up 3 units. So if we started at the origin here on the parent function, and then we had this plus 3, so that made us move up 3 units. So now we have a point here at 3 on the y-axis. So all that did, the x plus 3, is it moved that entire line up 3 units. Here's another example. Again, we have the parent function graphed here as the red line. So it goes through the origin at 0, 0. And then if we have this graph, f of x equals x minus 4, that just takes our parent function and it shifted it down 4 units. So now it goes through negative 4 because it was minus 4. So now we shifted it down 4. Now here are a few examples of this vertical shift. So whenever you add or subtract a number in your equation and it's not grouped in with the x, we'll talk about that in a minute. So whenever you add or subtract a number, that will shift your graph up or down, depending on if it's plus or minus. So let's look at the first one. We have y equals x minus 2. So I'm actually going to start by graphing the parent function. So the parent function goes through 0, 0, and it goes up 1 over 1, up 1 over 1, up 1 over 1, and I'll do that in both directions here. So this is the parent function. Now, thinking of the parent function as my starting place, now I'm going to graph this equation, y equals x minus 2. So I'm going to start with the parent function, and I'm just going to shift the entire thing down 2. So in the middle here, this will come down to 2 here. And then again, it's just going to go up 1 over 1, up 1 over 1, all the way. And I can go backwards as well. And I can draw that line. So that is what the graph of y equals x minus 2 would look like. Now if I look at the second equation, y equals the absolute value of x plus 5, again, I'm going to start by graphing the parent function. You don't have to do this every time, but I think it helps to illustrate what's happening here. So the parent function, if I were just to graph y equals the absolute value of x, that would look like this. It would start at the origin, 0, 0, and then it goes over 1, up 1, over 1, up 1. And it does that on both sides because it always comes out positive. And so this one looks like a V shape like this. Now again, I'm going to think of that parent function as my starting place. And now I'm going to graph this equation where I have y equals the absolute value of x plus 5. So I'm going to take the parent function and I'm going to shift the entire thing up 5. So my vertex will be up here at 5 now. And then I'm just still going to go up 1 over 1 on both sides, up 1 over 1. So now it's shifted up like this. The last example here is a quadratic. So again, I'm going to start with the parent function. So the parent function is y equals x squared. That one also starts at the origin, 0, 0. So a quadratic function looks like a parabola, which is kind of like a U shape. So it goes over 1, up 1 on both sides. And then it goes over 2, up 4. Over 2, up 4 on both sides. So the reason why it does that is because whatever number you plug in for x, you square it to get the y. So 1 times 1 is 1, 2 times 2 is 4. So if I were to go over 3, then this would go up 9. So you just square the x value to get the y value. So again, that is the parent function. Now I'm going to graph y equals x squared minus 4. So I'm just going to take the parent function and I'm going to shift it down 4. So now my vertex will be down here at negative 4. And again, I go over 1, up 1 on both sides, and then over 2, up 4 on both sides. So I just took that entire shape and just shifted it down 4. Now I'm going to talk about what will move a graph left or right. So that is when there is a number that's grouped in with the x or the variable. I have a few examples here. We don't usually think about this when we're graphing linear equations because on the first example, I could remove those parentheses and it would mean the same thing. So it still works technically, but we don't usually think about it that way with linear equations. But anyway, if the number is grouped in with the x and it's adding or subtracting, then that moves the graph left or right, and you want to think opposite. So in this first example where I have x minus 2, normally with minus you would think it goes to the left because that's where the x values are negative. But it's actually the opposite. It would go to the right. So that would move the graph right too. On the second example, we have the absolute value of x plus 3. So see how that 3 is grouped in with the x? It's inside the absolute value. Whereas like the previous examples would be something like this, like the absolute value plus 3. So that 3 is on the outside. It's not grouped in with the x, so that's when we would say it's up 3. But on this example here, the 3 is grouped in with the x, so that's when it moves left and right. And again, think opposite. So if it's plus 3, that's going to move it left 3. And then on the last example, we have x minus 5 squared, so that's going to move that graph right 5. Again, if it was the other one that we talked about, we would have the x squared and then the minus 5. So this is not grouped in with the x, so that's when we would go down 5. So if the number is adding or subtracting and it's not grouped together with the x, then that's up and down. If the number is grouped in with the x, then that would be left and right. And remember, with left and right, we think opposite. Now I'm going to graph these examples here. Again, I'm going to start with the parent functions. So with the linear equation, the parent function is just y equals x. So I'm just going to graph that line here. It goes through the origin, it goes over 1, up 1. And now I'm going to graph the x minus 2. Like I said earlier, with linear equations, you could remove the parentheses and it won't really change anything. So that's the same as y equals x minus 2 without the parentheses. So we talked about how that goes down 2 in this one. And then this one, I said it goes right to. So I'll show you that actually, it does the same thing on a linear equation. So let's just say I move it down 2, and then I go up 1 over 1 like this. So because it's a line, then it doesn't really matter. We could say that this came down 2, or we could say that this moved right 2. It kind of works both ways when it's a linear equation. Now I'll graph the second one, and again I will start with the parent function. So the parent function for absolute value starts at the origin, and then it goes up 1 over 1 in both directions, so it's like a V shape. And now, because of this plus 3 that's grouped inside the absolute value with the x, that is going to go left 3. So I'm just going to take that whole graph and move it left 1, 2, 3. So the vertex will be at -3, and then it still goes up 1 over 1 in both directions. Now I'm going to graph the third equation. So again, I'll graph the parent function first. I forgot to write the parent function over here, so that would be y equals the absolute value of x. So the parent function of the quadratic is y equals x squared. So again, that starts at 0, 0. It goes over 1, up 1 in both directions, and then it goes over 2, up 4 in both directions. So that is our parabola, which looks like a U shape. And now I'm going to graph this equation here. So where we have that -5, again, think opposite. So that's going to move it right 5. So instead of starting at the origin, my vertex is going to be over here at 5. And then again, it goes over 1, up 1 in both directions, and over 2, up 4 in both directions. And it's the U-shape parabola. Okay, so those are a few examples of how to use horizontal translations when we shift the graph left and right. Now here is an overview of when you have a number multiplying in front of the x. So in a linear equation, we would call this number the slope. That would be the m value in y equals mx plus b. So when you have a number multiplying in front of x, that will cause a vertical stretch or a vertical shrink. And I'll show you what that looks like on the graphs. When it's a whole number, 1, 2, 3, 4, 5, 6, etc., that will cause a vertical stretch. When it's a fraction or a decimal like 1/2, 2/3, 1/4, etc., that will cause a vertical shrink. The other thing this number does is if it is negative, then that will flip your graph over the x-axis, aka it will flip your graph upside down. So I'll show you a few examples of what this looks like. I'm still going to start with the parent function so you can see what the change is that occurs. So the parent function for the linear equation is y equals x. That starts at 0, 0. It goes up 1 over 1, up 1 over 1. Now, this 3 in front, that would be our slope or vertical stretch. So now we're still going to start at the origin at 0, 0. But instead of going up 1 over 1, I'm going to go up 3 over 1. Up 3 over 1. And I can go backwards, down 3, backwards 1, down 3, backwards 1. So then the line looks like this. That was not very straight. Okay, so you can see that that slope made that line steeper because it was a bigger number than 1, so the slope is steeper than 1. Now looking at the second equation, the parent function would be y equals the absolute value of x. So I will graph the parent function first. Starts at 0, 0. It goes up 1 over 1, up 1 over 1 in both directions. And now, because this one has a negative, that is going to flip the graph over the x-axis, which will flip it upside down. And then the 4 will cause a vertical stretch of 4. So I'll show you what that looks like. So we're still starting at 0, 0. And now, instead of going over 1, up 1, I'm going to go over 1, down 4. Because we're going down because it's negative, and we're going 4 units because of that 4 in front. So over 1, down 4. And so this is going to be a skinny V like this. So usually if it's a higher number, the skinnier it's going to get. And then the last example, again, I'll start with the parent function, y equals x squared. So that starts at 0, 0. It goes over 1, up 1 on both sides, and then over 2, up 4 on both sides. And then this one has a 1/2 in front. So this is going to be a vertical shrink. And so instead of going over 1, up 1, now I'm going to go over 1, up 1/2. So I still start at 0, 0. I go over 1, up 1/2. And then instead of going over 2, up 4, I'm cutting that number in half. So now I'll go over 2, up 2. Over 2, up 2. I'll put some more points because now it's reduced to half the size, so I can fit more points. So normally on the parent function, you would go over 3, up 9, because that is 3 squared is 9. So now we're cutting that number in half. So going over 3, now I'll go up half of 9, which is 4.5. So over 3, up 4.5. Okay, so you can kind of see this one will be a little bit wider than the parent function. So if that number is a fraction or a decimal, it's going to be wider than the parent function. If it's a whole number, like on the previous example, then it's going to be skinnier than the parent function. Now we are going to put it all together. So I showed you all of the graphs of the individual examples, like up and down, left and right, vertical stretch, vertical shrink. I did all of those individually. Now these graphs have all of those things combined. So we're putting everything we've learned together into one graph. And so I'll show you what that looks like. So starting with the first one is our linear example. So again, I'm going to graph the parent function first. So the parent function is y equals x. It starts at 0, 0. It goes up 1 over 1. So that is the parent function. And now these transformations tell me this plus 2 tells me it's going to go up 2. And then this 3 in front means we're going to have a stretch of 3. Or with linear equations, we usually think of that as our slope. And the 2 we normally think of as the y-intercept. So it's all the same thing. It still works either way. It's just different ways of explaining it. So we're going to move up 2. So I'll have a point up here at 2. And then instead of going up 1 over 1, I'm going to go up 3 over 1. So up 3 over 1. And I can go down 3 and backwards 1. Down 3, backwards 1. So our line will look something like that. Now looking at the second equation, again I'm going to start with the parent function, y equals the absolute value of x. So that starts at 0, 0. It goes up 1 over 1 on both sides. And now I'm going to look at my transformations. So this plus 3, we'll move it up 3. This minus 4, that's where we think opposite. So that's going to move it right 4. And then this 2 will be a stretch of 2. Okay, so let's start with the vertex. So the vertex is normally at 0, 0. But now it's going to go up 3 and right 4. So up 3, right 4. Now my vertex is going to be right here. And then normally it goes over 1, up 1, over 1, up 1, over 1, up 1. But because of this 2 out front, now it's going to go over 1, up 2, over 1, up 2 on both sides. Over 1, up 2, over 1, up 2. So now this is our new graph over here. So it moved right 4 and up 3, and we stretched it by a factor of 2. All right, now looking at the last one, our parent function for the quadratic is y equals x squared. So that starts at 0, 0. It goes over 1, up 1 on both sides, and then it goes over 2, up 4 on both sides. So that is our parent function. Now let's look at our transformations. So this plus 5, we'll move it up 5. This plus 1, again, think opposite, so that's going to go left 1. This 1/2 is going to be a shrink by a factor of 1/2. And then the negative is going to flip the graph upside down. Okay, so let's start with the vertex. So normally on the parent function, the vertex is at 0, 0. Now we're going to move the vertex up 5 and left 1. So up 5, left 1, here's our new vertex up here. And then we're flipping it upside down. We're shrinking it by 1/2. So normally it would go over 1, up 1. But now we're going to go down instead of up because of that negative. And instead of going over 1, down 1, we have this 1/2. So we're going to go over 1, down 1/2. So right here. Over 1, down 1/2. And then normally on the parent function, you go over 2, up 4. So now we're going to go over 2, and we're cutting that number in half. So instead of down 4, now we're going to go down 2. So over 2 and down 2. And then again, normally on the parent function, you go over 3, up 9. So now we're cutting that number in half. So we'll go over 3 and down 4.5. So about here. Over 3 and down 4.5. I could maybe even keep going. So normally on the parent function, you would go over 4, up 16. So now we're cutting the 16 in half. So I would go over 4 and down 8. 5, 6, 7, 8. So over 4 and down 8. Okay, so then we can draw our parabola. Okay, so we took the parent function, we shifted it left 1 and up 5, we flipped it upside down because of that negative, and we shrunk it by a factor of 1/2 because of that 1/2 out front. In summary, I gave you a list of equations over here on the left side because I want you to understand that these transformations work all across the board, any type of equation. So some of these we didn't look at today, but the transformations still work the same way. So I have a quadratic, I have an absolute value, and then I have a logarithm, a sine function, a cosine function, etc., because these transformations work the same way for all types of equations, which is pretty cool. So once you have these down, it can help you with any type of equation that you're graphing. So the A is the number that is multiplying out front, and that is your vertical stretch or shrink. It can also be a reflection if that number is negative. The H is the number that is being added or subtracted grouped in with the X. So in the parentheses with the X or in the absolute value with the X, whatever the equation is, if it's grouped in with the X and it's adding or subtracting, then that shifts your graph left and right. And then the K value is the number that is added or subtracted outside. So not grouped in with the X, it's usually at the end. So if you add or subtract a number at the end of your equation, then that will be your vertical shift, which will shift your graph up and down. So there is just a brief overview of how to transform graphs. I hope these tips were helpful. Please like and subscribe if you liked this video, and please let me know in the comments if there are any other math topics that you would like me to cover in a future video. Thank you so much for watching.